Quantum gravity is a field of theoretical physics that seeks to describe gravity according to the principles of quantum mechanics. It deals with environments in which neither gravitational nor quantum effects can be ignored, such as in the vicinity of black holes or similar compact astrophysical objects, such as neutron stars, as well as in the early stages of the universe, moments after the Big Bang. Here is an easy and interesting description of quantum gravity. Imagine that space-time, the fabric of the universe, is made up of tiny woven threads. Quantum gravity tries to describe how these threads behave at the smallest scales, where the laws of classical physics and general relativity break down. One way to think about quantum gravity is to imagine that space-time is not smooth, but rather made up of tiny bumps and lumps. These bumps and lumps are called Planck scale structures, and they are the smallest possible structures in the universe. At the Planck scale, gravity and quantum mechanics become intertwined. This means that we can't use the laws of classical physics to describe how gravity works at these scales. One of the main goals of quantum gravity is to develop a theory that can unify gravity with the other three fundamental forces of nature: electromagnetism, the strong nuclear force, and the weak nuclear force. If we can develop a unified theory of quantum gravity, it would help us to understand some of the most fundamental questions about the universe, such as how black holes work and what happened at the Big Bang. Here is an analogy that may help you to understand quantum gravity. Imagine that you have a trampoline. If you place a bowling ball on the trampoline, it will create a dip in the fabric of the trampoline. This dip is like the gravitational field of the bowling ball. Now imagine that you place a marble on the trampoline. The marble will roll towards the bowling ball because of the gravitational field. In quantum gravity, we can imagine that the fabric of space-time is like the trampoline. The Planck scale structures are like the bowling balls, and the particles of matter are like the marbles. Particles of matter move through space-time because of the gravitational fields of the Planck scale structures.